Okay, so in this video, we're going to continue with intermolecular forces recap, and then we're going to do a few exam questions in preparation for your test. So the first thing we need to understand is the difference between what we've been talking about previously, which is a bond, okay, a bond or chemical bond. So when we talk about a chemical bond, this is between two atoms. Okay, so we've got an atom coming together to form a chemical bond. The types of chemical bonds we've looked at was you've got your nonpolar bond, you've got a covalent bond, and you've got a ionic bond. How we figured out this was we found the change in electronegativity, and that gave us an understanding of whether we have a nonpolar. In that case, electronegativity change will be 0. Covalent should be around 0.1 up to 2, and if it's anything greater than 2,1, it's usually ionic. But now we are done with chemical bonds. Now we're talking about when we have atom 1 and atom 2 coming together, we understand that this is a molecule. And now what we want to focus on is if I've got a molecule here and another molecule here, so you can imagine like a glass or a jar with all of these molecules together. A good example would be if you talk about water, H2O. You've got all of these H2O molecules in the glass. And what we want to understand is, inside of this glass, what forces or what type of bond do we have holding the molecules together? Okay, so we refer to this bond as our intermolecular forces. Okay, and it comes from the definition name, intermolecular. It's between the molecules. So your intermolecular forces is what holds molecules together, while your chemical bond is what holds your atoms together. So now we obviously have to understand what types of intermolecular forces we have. So we have a whole list that we've gone through, 5 to be specific, of our intermolecular forces. When we're going into identifying intermolecular forces, one of the first things you must be able to do is being able to identify, firstly, an ion. Alright, we discussed what an ion is, and if you are confused, I think in the previous video, I think it's called 14 June, there is a list there where I gave you a worksheet of the common ions we deal with. So if you see something like H plus, Cl minus, these are usually ions because they've given off electrons so that now they've got an overall charge to them. Okay, so you have the ion. Something even like KCl is considered to be an ion. So that's your first thing, being able to identify an ion. Next, you must be able to identify something called a dipole. Now, a dipole is just another word for calling something a polar molecule. So recall in our previous videos, we talked about what is a polar molecule. And how you find out if something is polar, just quickly to go through that, is you first work out your change in electronegativity. If you get a number that is greater than 0, you then must check your shape of your element, and if your shape is unsymmetrical, then you are dealing with a polar molecule. So that's how you can tell if you've got a polar molecule and therefore a dipole. So you need to have an understanding of an ion, a dipole. You should also understand a nonpolar molecule. Okay, and that should be fine to be able to identify them. So the first type of intermolecular force we went through was something called an ion dipole. Now quickly what this is telling us is basically you've got an ion in your substance and you've got a polar molecule coming together. So if you find that you've got 2 of these, then you're dealing with an ion dipole intermolecular force. Secondly, we have a dipole-dipole. Now a dipole-dipole is basically 2 polar molecules coming together in our substance. Third, we have mutually induced dipole. We also call these our London forces. Okay, but they're also called mutually induced dipoles. And what this is basically you've got 2 non-polar molecules together to form this. Therefore, they are inducing a dipole on each other. Now, before we talked about a dipole-induced dipole. So in dipole-induced dipole, first we read dipole, so we're dealing with a polar molecule, and because it's an induced dipole, it's going to be a non-polar molecule. So you've got a polar and a non-polar molecule coming together. And the fifth one is usually very easy to remember. This is our hydrogen bond. And the hydrogen bond is usually the strongest bond of all of these intermolecular forces. And it's a special type of dipole-dipole force. And it's basically you identified by firstly you must have a hydrogen atom. And this hydrogen atom can either be bonded to oxygen, fluorine, or nitrogen. So an example of this would be H2O. You've got a hydrogen and oxygen. Therefore, if you look at water, the intermolecular force in water is going to be a hydrogen bond. You can also look at HF, hydrogen fluoride, and so on. So just to quickly look at the difference we've been talking about, if I say I'm talking about water and I want to know firstly what is the bond in water. If I'm talking about the bond in water, for here I'll go and find my change in electronegativity, get that value, which I think is going to be ionic. And if I'm talking about intermolecular force, for this, you need to now look at these headings. So here you can clearly see you're dealing with a hydrogen bond. So take note of the difference between a bond and intermolecular force. Okay, so this is basically the theory we dealt with for intermolecular force. You must be able to know a non-polar versus a polar, symmetrical versus non-symmetrical, be able to identify the shapes in your different molecules, being able to identify the type of bond you're dealing with. Is it non-polar, is it covalent or ionic? And lastly, intermolecular forces. You must be able to give them the type of intermolecular force you are dealing with. We're now going to go over to practice an exam type question, this question 4. So we're going to look at the graph together and we'll go through it. So firstly, what we have here is so we've got a graph here where you've got your boiling point versus your molecular size, right? And they're giving you 3 compounds. They're giving you CH4, C4H6, and C3H8. Okay, 4.1 is asking you to define what boiling point is. That's 4.1.1, and the definition which I'm going to read out is, it's basically when your vapor pressure of a substance is equal to the atmospheric pressure. 4.1.2, they want you to describe the trend in the boiling points of the compounds as shown in the graph. So I'm going to go through this fairly quickly because I think we've touched on this question before. I just wanted to re-emphasize vapor pressure. So that's why I'm doing it again. So if we're talking about 4.1.2, what is the trend in the graph? Whenever they ask you to describe trends, you're basically going to talk about as one quantity is changing, as it's increasing, what is happening to the other quantity. So in this case, you can clearly see that the boiling point is increasing from A to C. Or as your boiling point is increasing, so is your molecular size. 4.1.3, explain that answer by referring to molecular size, type, and strength of intermolecular forces. So the answer they're looking for here is, I'm going to write it down here. Firstly, they want you to say that the molecular mass is increasing from A to C. Okay, so we understand that. Then the strength of the London forces, so you could say the strength of your intermolecular forces is increasing. Now, it would be good for you to go and specify what are the intermolecular forces here. And you can see that you've got your London forces here, or you could call them induced dipole, right? So you could say London forces. That's 4.1.3. 4.1.4, which one of the compounds has the highest vapor pressure? Explain the answer by referring to the data on the graph. So the compound, you can pause the video and figure out your answer, but if we're talking about highest vapor pressure, this is what I wanted to deal with. Let's go to our theory and let's understand what's going on. If we can imagine you've got a pot and you are boiling water in this pot. Okay, there's a few things to take note of in this case, right? So we can say we are boiling water or any substance really. Okay, we know that if there is strong intermolecular forces, this means that you can imagine that there's a lot of glue between the particles. So the particles want to stick together, and they really want to basically stick to the bottom of the pot, right? And therefore, we're going to have, if we've got strong intermolecular forces, we've got a weak vapor pressure, or a very low vapor pressure. So that's the correlation between these two, and that's something we have to remember. The higher the boiling point means that we've got stronger intermolecular forces, and stronger intermolecular forces means you've got a lower vapor pressure. Okay, for the reason I've described. It's almost like that glue, which is the intermolecular force, is so strong that it's holding all the particles to the bottom of the pan. And we know vapor pressure is understood to be, if this is our pot, vapor pressure is the pressure wanting to escape from the pan. But because the intermolecular force is so strong, that's not going to happen. Therefore, you're dealing with a very low vapor pressure. So in this case, if they want us to state which one of the compounds has the highest vapor pressure, you can understand highest vapor pressure by saying the opposite. Highest vapor pressure means lowest boiling point. So they're basically the inverse of each other, right? A very high vapor pressure is a very low boiling point. So we look for the one with the lowest boiling point, which we can see to be A. So that would be our answer there. It's going to be A. Okay, question 4.2.1. They're giving you a table and they're giving you the molecular mass and boiling point, and they're asking you to calculate the molecular mass, which we haven't done, so we're going to leave that out. Then they want you to explain the difference in the boiling points by referring to the type and strength of the intermolecular forces. So just as a guide for this question of how you should answer it, first you need to state for pH3 what type of intermolecular force you have, and here it should be London forces. Then you go to NH3. What type of intermolecular force do you have here? Hydrogen bond. Then you need to compare your London forces versus your hydrogen bond. And based on that, you're going to get 3 marks for that. Okay, so that was just a recap of that question. We're also going to quickly look at this other question, also similarly dealing with bond energy now and bond length. So in this question, you've got a group of learners deciding to investigate the relationship between bond length and bond energy. And then they've collected data they're showing you in the table. So in 6.1, they want you to write down an investigative question for this investigation. Now, how do we do an investigative question? Firstly, it must be phrased. So some of the clues is you always want to start off the question with a question word, so like what, where, or how. Okay, these not necessarily where, but more so what and how. Okay, these are question words, so you always want to start it off using that. So we're going to say what. If we read the description again, they've told us that they want to investigate the relationship between bond length and bond energy. So a simple way of describing this would be, what is the relationship between bond energy and bond length? Okay, and don't forget to also include the question mark. So that's 2 marks. How the memo awards marks for this is, firstly, they want to see that you've identified the 2 variables, bond energy and bond length. So if you've written those 2 variables in your question, that's 1 mark. And the second is you must be able to start with the word what and have your question mark. So it must be in the form of a question. If someone went and wrote the relationship between bond energy and bond length, you won't get that mark for a question, right? They wanted a question. 6.2, apart from the bond length, name 2 other factors that has an influence on bond energy. Okay, so recall in the slides we've gone through previously, we talked about bond energy and the different factors that influence it. So you can pause the video and figure out what are any other 2 factors influencing our bond energy. And remember, bond energy is a description of how many moles does it take, or how much of energy is required to break 1 mole of an atom in a bond. So some of the answers you could have included was firstly size of the atom. The other one is bond order. Or even if you said number of bonds, that's the same thing. Okay, so any 3 of these would give you a mark here. So the next part, year 6.3, we haven't done this yet. This should be next term's work. So we're going to just exclude that. We're going to move on to this other question down here. And we're going to answer this. So again, if you want to take the time to pause the video, answer the question, and then you can go through the answers as we go through it, that is fine. So if we're going through this question, 7.1, we need to define the term electronegativity. So according to our guideline and how they're going to give you marks for this, electronegativity is defined as the measure. Just going to zoom out a bit. Okay, so you're going to get 2 marks for stating measure of tendency of an atom to attract bonding electrons. 7.2, we want to explain the difference between a polar molecule and a non-polar molecule. So what are the words they're looking for to give you a mark for this? Firstly, when you're talking about a polar molecule, you want to use the words like there is an uneven charge distribution. So, sorry, my thing is just stuck. So we want to say uneven charge distribution. That's 1 mark. And therefore, because it's an uneven charge distribution, what happens is you're going to get one end is going to become slightly positive, and the other end is going to become slightly negative. Okay, so if you look at a picture, what's going to happen is you're going to have a slightly positive end on one side and a slightly negative end on the other side. Therefore, it's a polar molecule. So you're going to get 2 marks for saying that, or 1 mark rather. And then if you're talking about a non-polar molecule, we describe this saying that there is an even charge distribution. Okay, so there is an even charge distribution. So if you can imagine your molecule or your atom, it looks like this. Sorry, this should be positive there. So if you have a positive here, you've got negative, positive, negative, and so on, right? So that there's an even distribution of the charge. And that is for 2 marks. The 7.3, you've got a table below that shows the properties of methane, which is CH4, and chloromethane, which is CH3Cl. Okay, so they're giving you a table, they're giving you the molecular formula, the structure of what it looks like, the shape, and the type of molecule. So you can see that CH4 is non-polar, while CH3Cl is polar. And they want you to firstly explain why CH4 is a non-polar molecule. So since we've done this question as well previously, I'm just going to give you the pointers of where the marks are allocated. So if you're saying something is non-polar, the first thing they want to give you a mark for is firstly saying that there is a symmetrical charge distribution. Remember, symmetrical, if you want to use the word even, it's the same thing, and charge distribution. Okay, that's number 1. And the next thing they're giving you a mark for is saying that there is no oppositely charged poles. So the same thing like here, right? There's an even distribution, therefore no oppositely charged poles. Okay, and then 732, a chlorine atom replaces one of the hydrogen atoms in the methane molecule to form a chloromethane molecule. Both molecules have the same shape, right? You can see they're both tetrahedral. But they want you to explain why the chloromethane molecule that forms is polar. And this is for 3 marks. So again, where are we getting our marks allocated here? The first thing is to say that chlorine, Cl, is more electronegative than carbon, okay, which is capital C. So if you go to your periodic table, you will notice that the number for chlorine is a much stronger electronegativity than carbon, right? It's higher. And because it's higher, it therefore makes chlorine is going to be slightly more negative. So because it has a greater electronegativity, this makes chlorine more electronegative. And this results in so since there are distinct positive and negative ends, the charge distribution surrounding the atom is not identical. So you can see it's going back to the thing where they want you to say there is an uneven charge distribution. Okay, and that's why it makes it polar. Okay, so this was a recap of some of our exam questions we've gone through, and a recap of the theory that you would most likely need to review again. I'm just checking if I left out anything. So yeah, most of the stuff is basically just going over the theory. I would advise you to go through most of your definitions, making sure you are not leaving out important words. If you haven't memorized the shape table or the electronegativity table, a good idea is to do that now. Also just, practicing more of the questions. At this point, you should be reviewing what have you been getting wrong and making sure you understand those fundamental things. You'd notice that the past 2 papers tend to ask mostly the same questions, just using different elements. So making sure if you know how to draw, for instance, a Lewis structure, you know how to identify non-polar molecule, whether it's symmetrical, the intermolecular forces, and so on. And if you do have any questions, if you're confused about any concept or anything that's bugging you, feel free to message me and we can always just quickly go over it on a one-to-one session. So I wish you guys all the best for tomorrow, and just remember as well that today is our last lesson. The next time I will see you should be in the first week of July.